So let's look now at completing the square. We know a perfect square will factorise as follows, so I can rearrange this to give x squared plus 2ax is equal to x plus a all squared minus a squared. And this is a useful fact that we'll use again and again, which is why it's in the top right hand corner. Applying that to the first question, what we will do is simply half the coefficient of x, which is 3, and then remove 3 squared, which will be 9. In the second case, we're dealing with fractions, where we always want to deal with fractions because they're so much easier to manipulate than decimals. I want to take half of negative 7 over 2, which is going to be x minus 7 over 4 squared, and then when it comes to squaring that fraction, I just get 49 over 16, which is far simpler than trying to square 1.75. In the next example, my coefficient of x squared is no longer 1, so I start by factorising to make the coefficient of x squared 1, which is going to give me this. Then continue as normal, so half the coefficient of x, which would be 5 over 2 squared, minus 25 over 4, and expanding by the 3 would give me 3 lots of x minus 5 over 2 squared minus 75 over 4. In the final example, the question is presented slightly differently, so I'm just going to rearrange it to give it a form that I'm more used to. Again, recognising that the coefficient of x squared is no longer 1, so I take out that factor of negative 1 to leave me with x squared minus 3x, and then complete the square as normal, which would be x minus 3 over 2 squared minus 9 over 4, and then finally put the negative through the bracket, which is going to be minus x minus 3 over 2 squared plus 9 over 4. I just want to tidy these up for completeness. When we're dealing with constants, we forget about the constant until the very end. So in this case, I would have x squared plus, not even that, I would have x plus 2 all squared minus 4 minus the 1. And then we collect the terms at the end, so I've got x plus 2 all squared minus 5. In the next example, again, I'm going to ignore the constant. This time I have to factorise again, so that's going to give me 2 lots of x squared minus a half of x. Leave the 4 on the end, which is 2 lots of a half is a quarter, so that's x minus a quarter squared minus a 16th minus 4. Expanding gives me 2 lots of x minus a quarter squared minus an 1/8, and then minus that 4, and again collecting at the end I've got x minus a quarter squared minus 33 over 8. Typically we use completing the square to solve quadratics. Now the first step in solving a quadratic would be to see whether it factorised, so I would look at the equation equal to 0, which would give me the following, and I would look for two numbers that had a product of negative 7 and a product of negative 9 and a sum of negative 7, and I realised that those numbers don't exist. Now because this is an equation, I can just simply divide everything through by 3 rather than taking a factor out, so this becomes x squared minus 7 over 3 x minus 1 equals 0. Now I complete the square in the same way, so this is x minus 7 over 6 squared minus 49 over 36 minus 1 is equal to 0. So that would give me x minus 7 over 6 squared, and then combining these is going to give me 85 over 36. At this point we square root, and whenever we square root we're going to get two possible solutions, so plus or minus the square root of 85 over 36, and then finally adding the 7 over 6 onto both sides, I've got 7 over 6 plus or minus the square root of 85 over the square root of 36, which is 6. So perhaps a nicer way to present this solution would be x is 1/6 of 7 plus or minus the square root of 85. Let's finish off just by having a quick look at an exam question. So I'm looking at something here which isn't telling me to complete the square, but I can see a completed square version in it. So what I'm going to do is start off by rewriting my first side as x squared plus 4x minus 5. I'm going to factorise out the minus 1 from x squared and the positive 4x, and then still leave the minus 5 as is. And in my next step I'm going to complete the square, so that becomes x minus 2 all squared minus 4 minus the 5, tidy that up. Put in the negative through the bracket gives me x minus 2 all squared plus 4 minus the 5, which is minus x minus 2 all squared minus 1, or rather minus 1 minus x minus 2 all squared. So here is q and here is p, so I'd finish off by saying that p was equal to negative 2 and that q was equal to negative 1.